This is a video about how to solve a quadratic equation using the square root method. The first step is that you have to get the squared term by itself. In this case, we already have the squared term by itself. The second step is to take the square root of both sides. When you take the square root of a squared term, the square root and the square cancel out, and you're left with just x. And then the square root of 9 is actually a whole number. It is 3. So we're going to take the square root of 9. We're going to write the 3. And whenever you take the square root, it actually can be a positive or negative 3. So we call that plus or minus 3. That is because 3 times 3 equals positive 9. And negative 3 times negative 3 equals positive 9. So they both work. The third step would be to solve for x if you needed to, but I already have x by itself. The fourth step is just to write the exact and approximate answers. So we have one answer that can be x equals a positive 3. Right, we can use the plus sign and get a positive 3. The other answer could be a negative 3. So x equals negative 3. There's no need to approximate them since they just equal regular numbers. So we have our two answers here. A similar problem is if I have x squared equals 7. Once again, the first step is to get the squared term by itself. And in this case, it already is. The second step is to take the square root of both sides. When you take the square root of both sides, the square root and the square cancel out. And in this case, it leaves us with just an x. And remember, when I take the square root of a number, it needs to be a plus or a minus. So that always goes there. But there is not a whole number that's the square root of 7. You can even check that in the calculator. If you go to Desmos, you type in the square root of 7, it ends up as a decimal. It's not a whole number. So since it's a decimal, I'm going to leave it as the square root of 7. The third step is to solve for x, which I've already done. And the fourth step is to split up your answers, because remember, you have a positive answer for the plus. So we have a positive square root of 7. And we also have x equals a negative square root of 7. These would be called your exact answers. We can write decimal approximations for them by doing squiggly equal sign and typing them into Desmos. So in Desmos, I have the square root of 7 already. Now I want the negative square root of 7. And you should approximate to 3 places after the decimal point. So I have 2.645 for the positive one. And for the negative one, 645. And for the negative one, I have negative 2.645. So these are my 2 decimal approximations. Now the problems can get more complicated. Remember, the first step is to get that squared term by itself. So I want to get the x minus 8 quantity squared by itself. I need to get rid of this 4 out front. Well, the 4 is being multiplied by the squared term, so we are going to divide both sides by 4. So these 4 cancel out, and I'm left with x minus 8 squared equals 20 divided by 4. Well, that equals 5. Now the second step, if you remember, is to take the square root of both sides. The square root and the square cancel out, which leaves us with x minus 8. And there is not a square root of 5. It comes out to be a decimal. So I'm going to leave this side as plus or minus the square root of 5. My next step is to solve for x. X isn't by itself and we need it to be. So I'm going to do the opposite of subtracting 8, which is add 8 on both sides. So you get x equals, and this 8 comes first. It's going to be 8, then the plus or minus square root of 5. Go ahead and break up your two answers. One answer is going to have the plus sign. So it's going to be x equals 8 plus square root 5. Your other answer is x equals 8 with the minus sign, minus square root 5. Those are our exact answers. To get the approximate answers, you put those in Desmos. So we're going to do 8 plus the square root of 5, and then 8 minus the square root of 5. So one answer is 10.236. That's for the plus answer. For the minus answer, you get 5.763. We're just using 3 places after the decimal. So this is approximately 10.236. And the other one was approximately 5.763. We have one more problem with multiple steps in it. So remember that your first step is always to try to get the squared term by itself. So I need to get rid of this minus 1. That's right there. In order to get rid of it, you do the opposite. So I'm going to be adding 1 to both sides. So these ones cancel, and I'm left with 3x plus 2 squared equals 16. Remember, your second step is to take the square root of both sides. The square root and the square cancel out, which leaves us with 3x plus 2. And the square root of 16, that is a whole number, so we can use it. Don't forget your plus or minus. And then the square root of 16 is 4, because 4 times 4 makes 16, and negative 4 times negative 4 makes 16. Now your next step, the third step, is to solve for x. So I'm going to subtract 2 on both sides. We get 3x equals negative 2 plus or minus 4. And then I need to get rid of the 3 in front, so I'm going to divide both sides by 3. X equals negative 2 plus or minus 4 divided by 3. Now that we have x by itself, we're going to split up our two answers. So remember, one answer has this plus sign. X equals negative 2 plus 4 divided by 3. The other answer has the minus sign. X equals negative 2 minus 4 divided by 3. Those are our exact answers. Then we just need to put them in Desmos to come up with our approximate answers. So put your squiggly equal signs, and then put those two things in Desmos. Make it a fraction, negative 2 plus 4 divided by 3. And then we have another fraction, negative 2 minus 4 divided by 3. So we get 0.666. When you see this little circle with the 2 boxes in there, it means it converts it to a fraction. So you can use either one, 0.666 or 2/3. And then the other answer was negative 2. Since this is just the whole number, we should change that to a regular equal sign, not an approximate. Approximate answers are used for when you have a decimal that doesn't end, all right, and you're rounding it.